Your agent makes the tests go green, then the first real input explodes. What if every idea had to squeeze through a tiny hourglass and the model could only speak in two symbols? Long contexts mix examples, code, and error logs into one swirl, so a powerful coder does what it does best, patches. It anchors on quirks, overfits with brittle if-elses, and ships a win that won't generalize. So how do we stop the swirl without retraining? The researchers say it isn't better wording. It's a choke point that forces information to compress into a rule. A tiny neck in the glass, but what exactly squeezes through? Picture the hourglass tightening. Every chaotic grain is forced to choose, belong to a schema of the world or to a transformation that acts on it. Two strands, phi and t, slip through, everything else stays above. If that's the shape, how does the workflow feel in your hands? Now we run the sand through, one clean pass at a time, four stateless calls that never share drafts. We induce, we deduce, we compile, we refine, but fixes must touch phi or t, not the code. And yet, how exactly does that kill shortcuts? Watch the neck. Here's the reveal. On the left, self-refine lets drafts, errors, and code swirl in one chamber, shortcuts seep across. On the right, the neck clamps down, only phi and t pass. So any correction must rewrite the rule, not patch the artifact. That's why a frozen model suddenly generalizes. Proof it isn't just pretty glass. RKGI 2 jumps by 814 points, Verilog nearly doubles for GPT 5.5, and even minimal prompts win as long as phi and t stay isolated. The rule, not the wording, does the lifting. To use it tomorrow, split your workflow into isolated calls, pass only phi and t forward, and regenerate from scratch after each refinement. Expect 2-3 times tokens, but when correctness matters, the hourglass pays for itself, and scales with pass at 2 consensus. Cut the context, force the hourglass. If a change doesn't revise phi or t, it's not learning, it's patching. If this helped, subscribe to AI Admirals. We turn dense papers into deployable moves.